Long before telescopes pierced the night sky, before calculators crunched numbers in milliseconds, an ancient civilization gazed upward and saw what others couldn't: patterns hidden in the stars, secrets whispered by the planets. The Mayans didn't just observe the cosmos, they decoded it with a mathematical system so precise, so revolutionary, it allowed them to track worlds they couldn't even see. Picture this: a culture without modern instruments, yet one that calculated the orbits of distant planets with staggering accuracy, predicted celestial events centuries in advance, and built entire calendars synchronized to the dance of the heavens. How, through a forgotten language of numbers, a code etched into temples and manuscripts, waiting centuries to be understood. This isn't just a story about ancient math, it's a revelation. The Mayans didn't rely on guesswork or mythology to map the sky. They used a sophisticated system of calculations, a blend of astronomy and pure numerical genius that modern scientists are only beginning to unravel. Think about that for a moment. A civilization separated from us by over 1,000 years, yet their work rivals what we achieve today with supercomputers and satellites. Their equations didn't just measure time or track Venus, they revealed the invisible, charting the paths of planets like Mars and Jupiter long before telescopes brought them into focus. What did they know that we've overlooked, and why was this knowledge lost to history? The answers lie in the ruins of their cities, in the cryptic glyphs that line their pyramids, and in the fragments of bark paper books that survived the ravages of time. This video is your guide to uncovering those secrets. Together, we'll piece together the forgotten math that let the Mayans conquer the cosmos, explore why their system vanished from use, and discover how modern researchers are finally bringing their brilliance back to light. It's a journey through time, across continents, and into the mind of a culture that saw numbers not just as tools, but as keys to the universe itself. So settle in, because what you're about to learn will change the way you see the stars, the past, and the astonishing power of human curiosity. The Mayan civilization didn't just track time, they mastered it. While other ancient cultures struggled to align their calendars with the seasons, the Mayans developed multiple interlocking systems so precise they could predict celestial events down to the day, centuries in advance. At the heart of this achievement was their Vigesimal numbering system, a base 20 method that transformed abstract calculations into a language of the cosmos. Unlike our familiar base 10 system, theirs used just 3 symbols: a dot for 1, a bar for 5, and a shell for 0. But this seemingly simple code held extraordinary power. Take their long count calendar, for example. While we measure years in linear sequences, the Mayans saw time as a series of nested cycles, like gears in a celestial clock. They calculated the length of a solar year at 365.242 days, astonishingly close to our modern measurement of 365.2422. Even more impressively, they synchronized this with the cycles of Venus, which they tracked to within 2 hours over 500 years. How? By observing the planet's movements not as isolated events, but as part of a grand numerical pattern. Every time Venus appeared as the morning or evening star, they recorded its position, building a database of celestial rhythms that spanned generations. But their genius didn't stop there. Hidden within their temples are architectural alignments that functioned as giant astronomical calculators. At sites like Chichen Itza, the stairways of El Castillo Pyramid cast shadows during equinoxes that resemble a serpent slithering down the steps, a visual marker of celestial events encoded in stone. Meanwhile, the windows of the Caracol Observatory were precisely angled to frame the extremes of Venus's path across the sky. These weren't just monuments, they were equations in physical form, blending math and mythology into a single science. What's truly remarkable is how they applied this knowledge to the invisible. Without telescopes, the Mayans deduced the existence of planets like Jupiter and Saturn by tracking subtle irregularities in the motions of visible stars. They even accounted for their elliptical orbits, something European astronomers wouldn't grasp until Kepler in the 17th century. Their Dresden Codex, one of the few surviving Mayan books, contains tables predicting eclipses and planetary alignments with eerie accuracy, proving their math wasn't just theoretical, it was a working tool for navigating the cosmos. Yet perhaps the most fascinating question isn't how they did it, but why. For the Mayans, numbers were more than tools, they were sacred. Their calculations connected earthly life to the movements of gods, tying harvests to Venus cycles and coronations to celestial omens. This wasn't just astronomy, it was a dialogue with the universe, one where mathematics served as the translator between the seen and the unseen. And as modern researchers decode more of their glyphs and alignments, we're realizing just how much of their cosmic conversation we've yet to understand. The Mayans didn't just count differently, they thought differently. While the rest of the ancient world relied on base 10 systems, likely because we have 10 fingers, the Mayans built their mathematics around the number 20. This Vigesimal system wasn't just a quirk, it was a computational superpower. Imagine trying to measure the vast cycles of the cosmos with only the numbers 1 through 10. It would be like using a teaspoon to empty an ocean. But by grouping numbers in 20s, the Mayans could compress enormous calculations into elegant, manageable steps. A single digit in their system could represent values up to 19, and each subsequent position multiplied by 20, creating a ladder that could reach astronomical heights without toppling under its own weight. What made this even more revolutionary was their use of zero. While ancient Greeks and Romans struggled with the concept of nothingness as a number, Mayan mathematicians treated zero with the same respect as any other digit. This wasn't just a placeholder, it was a tool that unlocked the door to advanced arithmetic. With zero, they could perform precise subtraction, track intervals between celestial events, and even calculate dates thousands of years into the past or future. Picture their scribes recording the position of Venus not just for a single year, but across 5 centuries, all without a single error in their tables. That's the power of a numbering system designed for the infinite. But why 20? Some scholars believe it came from counting fingers and toes, while others suggest it mirrored their agricultural cycles or the sacred count of days in their calendar. Whatever the origin, this system gave them an edge no other culture possessed. When European astronomers centuries later wrestled with planetary motions using clunky Roman numerals, the Mayans had already streamlined the process. Their numbers flowed like poetry, dots and bars stacking vertically, each tier representing a higher order of magnitude. A single column could denote days, months, or even millennia, all with the same graceful efficiency. This mathematical elegance wasn't just for show. It allowed them to solve problems that would stump other civilizations for generations. Take their famous Venus table in the Dresden Codex. By using base 20, they could compress 65 Venus cycles, a span of 104 years, into a single, coherent calculation. They didn't need fractions or complex notation. Their system handled the math naturally, like a language perfectly suited to its subject. And when they needed to adjust for tiny discrepancies over centuries, their Vigesimal framework made those corrections seamless. It's as if they built a cosmic clock where every gear turned in multiples of 20, each click perfectly synchronized to the heavens. Yet the real marvel isn't just that they invented this system, it's how intuitively it mapped onto their world. Their calendars, their architecture, even their myths were steeped in this mathematical logic. The steps of a pyramid might mirror the tiers of their numbering system, each level a higher power of 20. A king's reign could be measured not in years, but in cycles that resonated with their base 20 rhythm. This wasn't just math for calculation, it was math as cosmology, a way of weaving time and space into a single, coherent tapestry. And as we'll see next, that tapestry held patterns even modern computers struggle to replicate. Among the handful of Mayan texts that escaped destruction, the Dresden Codex shines like a beacon in the night, a 74-page bark paper book filled with numbers, gods, and celestial secrets. Unlike anything else from the ancient world, this isn't just a religious text or a king's chronicle. It's a working astronomer's manual, a mathematical playbook for predicting the cosmos. Flip through its weathered pages, and you'll find tables so meticulously calculated, they rival modern astronomical almanacs. Take the Venus table, stretching across 5 pages. It maps the planet's entire 584-day cycle, breaking it down into intervals so precise, they're accurate to within a single day over 5 centuries. But the Codex isn't just about Venus. Tucked between its red and black glyphs are references to Mars, Jupiter, and even solar eclipses, events the Mayans tracked without lenses or telescopes. One section outlines a 78-day Mars cycle, while another predicts lunar eclipses with a rhythm so consistent, it repeats every 11,960 days. How did they achieve this? Through a blend of obsessive observation and numerical ingenuity. The Codex doesn't just record data, it reveals a system where every celestial event was plugged into a grander equation, like pieces of a puzzle only the Mayans could solve. What's truly mind-bending is how they corrected for errors. Over centuries, tiny discrepancies would creep into their predictions, a fact modern astronomers know all too well. But the Mayans didn't ignore these gaps, they fixed them. Hidden in the margins of the Dresden Codex are adjustment tables, subtle numerical tweaks that realign their calculations with the actual sky. It's as if they built a self-correcting algorithm, one that compensated for the universe's imperfections long before computers existed. Yet the Codex isn't cold mathematics. Every chart is woven with mythology, tying planets to gods and eclipses to omens. Venus isn't just a dot of light, it's Kukulkan, the feathered serpent, whose appearances dictated war or harvest. Eclipses were battles between celestial deities, their outcomes foretold by the numbers. This fusion of science and storytelling reveals something profound. To the Mayans, the cosmos wasn't a machine to be dissected, but a living, breathing entity speaking through numbers. And the Dresden Codex, it was their translator. Today, scholars are still uncovering its secrets. Recent scans revealed hidden layers of calculations beneath the visible ink, suggesting earlier drafts or even more advanced lost text. Some pages remain untranslated, their glyphs holding mysteries we've yet to crack. But one thing is clear, this battered book is more than a relic. It's a testament to a civilization that didn't just watch the stars, it conversed with them, using a language of dots, bars, and shells we're only beginning to fully understand. The Venus table in the Dresden Codex isn't just a record, it's a masterpiece of celestial engineering. Imagine tracking a planet's every move across the sky without lenses or satellites, relying solely on naked eye observations and a numerical system so refined, it could predict Venus's dance centuries into the future. The Mayans didn't just note its appearances, they mapped its entire 584-day cycle with a precision that defies belief. Their calculations were off by less than 2 hours over 500 years, a margin of error so slim, modern astronomers still marvel at it. What makes this even more astonishing is how they accounted for retrograde motion. To the naked eye, Venus doesn't just glide smoothly across the sky, it occasionally loops backward, a celestial illusion caused by Earth overtaking it in orbit. While European scholars like Ptolemy struggled to explain this phenomenon with convoluted epicycles, the Mayans treated it as just another variable in their equations. Their Venus table doesn't just mark the planet's positions, it anticipates these backward loops, weaving them seamlessly into the rhythm of its predictions. The secret lay in their relentless observation. Generation after generation, Mayan astronomers meticulously recorded Venus's movements, building a database of celestial patterns that spanned lifetimes. They noticed how its appearances as the morning and evening star followed a strict 584-day cadence, broken only by those brief retrograde interludes. Instead of dismissing these deviations as anomalies, they factored them in, adjusting their calculations like a cosmic clockmaker, fine-tuning a delicate mechanism. But here's the real kicker: their math wasn't just accurate, it was scalable. The Venus table doesn't just cover one cycle, it stacks 65 of them, spanning 104 years, into a single coherent framework. This wasn't a short-term almanac, it was a perpetual celestial calendar designed to outlast the astronomers who created it. And hidden within its rows of dots and bars are correction factors, subtle numerical tweaks that compensated for the tiniest discrepancies over time. It's as if they'd invented an ancient version of error-correcting code, ensuring their predictions stayed locked in sync with the heavens. Why go to such lengths? For the Mayans, Venus wasn't just a point of light. It was Kukulkan, the feathered serpent god whose movements dictated wars, coronations, and harvests. A misstep in their calculations could mean misreading divine will with real-world consequences. This fusion of astronomy and mythology drove them to refine their math to near perfection, blending empirical observation with sacred duty. Today, the Venus table stands as a testament to what's possible when human curiosity meets mathematical genius. While modern telescopes and supercomputers have eclipsed naked-eye astronomy, the Mayans remind us that precision isn't just about technology, it's about patience, pattern recognition, and the audacity to decode the cosmos with nothing but numbers and the naked eye. And as we'll see next, their legacy didn't end with Venus. The same math that tracked its path also unlocked the secrets of worlds they couldn't even see. The Mayans didn't just use zero, they gave it power. While other ancient cultures struggled with the abstract concept of nothingness, Mayan mathematicians embraced it as a fundamental force in their calculations. That simple shell symbol in their Vigesimal system wasn't just a placeholder, it was the key that unlocked the universe's deepest rhythms. Picture an astronomer tracking Venus across generations without a way to mark its absence during daytime periods or the gaps between celestial cycles. Without zero, those calculations would collapse like a pyramid missing its cornerstone. What made their zero revolutionary was how they applied it to place value notation, the same system we use today where a digit's position determines its worth. In our base 10 system, the number 502 relies on 0 to separate the 5 and 2. The Mayans did this vertically, stacking dots and bars where each higher position represented 20 times the one below it. A 0 in the third tier could transform a calculation from tracking days to predicting eclipses centuries away. This wasn't just math, it was temporal architecture, building bridges across time itself. Consider the challenge of their long count calendar, which spanned over 5,000 years. Recording such vast stretches required marking periods when certain celestial events didn't occur, a problem other civilizations fumbled with awkward workarounds. The Mayans' zero elegantly solved this, acting as both a pause button and a reset switch in their cosmic equations. When European monks were still writing out 400 and none in their ledgers, Mayan scribes were calculating the exact day Venus would reappear after months of invisibility, their zeros holding space for the unseen. The genius of their system becomes clear when you compare it to contemporaries like the Romans. Try multiplying 268 by 145 using Roman numerals, and you'll face a page of tangled symbols. But a Mayan mathematician could arrange the same problem vertically, using zeros to maintain place values, and solve it with the efficiency of modern arithmetic. This fluidity let them compress massive astronomical timelines into compact tables like those in the Dresden Codex, where a single column of symbols could represent millennia of planetary motion. Yet perhaps the most profound aspect of their zero was how it reflected their worldview. Where other cultures feared the void, the Mayans saw it as fertile ground. Their zero wasn't empty, it was potential, the silent beat between drum strikes that gives rhythm meaning. In their cosmology, the absence of a celestial body was just as significant as its presence, and their mathematics honored that balance. This philosophical depth, paired with practical brilliance, created a numbering system that didn't just describe the cosmos, it danced with it. Modern researchers are still unraveling the full implications of this discovery. Recent studies suggest the Mayans may have used zero in ways we're only beginning to understand, like calculating the invisible phases of planets or creating mathematical models of cosmic cycles too vast for other ancient cultures to conceive. Every time scholars decode another glyph or temple alignment, they find zeros woven into the fabric of Mayan science, proving this wasn't just a numerical tool, it was the silent engine behind their celestial mastery. The Mayan approach to time wasn't linear, it was fractal. While modern calendars march forward in a straight line, their system resembled an intricate clockwork of interlocking wheels, each turning at its own pace yet perfectly synchronized with the others. At the heart of this mechanism were two primary cycles, the 260-day Tzolk'in and the 365-day Hob. The Tzolk'in, often called the Sacred Round, wasn't just a count of days, it was a spiritual compass, blending 20 named days with 13 numbers to create 260 unique combinations. Each day carried its own energy, a cosmic fingerprint influencing everything from agricultural cycles to royal coronations. But the Hob mirrored the solar year, dividing 365 days into 18 months of 20 days each, plus a brief 5-day period considered highly auspicious. Alone, these calendars were remarkable. Together, they formed something extraordinary. Every 52 years, the Tzolk'in and Hob would realign, completing what the Mayans called a calendar round a span of time so significant. It marked the renewal of temples, the extinguishing and relighting of sacred fires, and the rewriting of history. Imagine a culture so attuned to time's rhythms that they built entire ceremonies around mathematical harmony. Then there was the long count, the grand orchestrator of Mayan timekeeping. Unlike the cyclical Tzolk'in and Hob, this calendar stretched forward and backward across millennia, anchoring events to a fixed point in the distant past. Its units kins days, unals 20 days, tons 360 days, catons 7,200 days, and bactons 144,000 days, stacked like tiers of a pyramid, allowing scribes to pinpoint dates thousands of years apart with surgical precision. A single long count inscription could connect a king's reign to the movements of Venus, the completion of a temple to the position of Jupiter, weaving human history into the fabric of the cosmos. What's truly staggering is how these calendars interacted. The Mayans didn't just track time, they choreographed it. A planting date might align with both a Tzolk'in day of fertility and a Hob month of rain, while a battle could be timed to coincide with Venus rising as the morning star. Their Dresden Codex even contains tables showing how these cycles overlapped with planetary movements, creating a multidimensional map of time where celestial events, agricultural needs, and human rituals existed in perfect sync. But the real magic lay in their corrections. The Mayans knew their 365-day hop drifted slightly from the true solar year. Instead of ignoring this, they accounted for it by cross-referencing with Venus cycles and eclipse tables, effectively creating a built-in error-checking system. It's as if they designed time itself to be self-correcting, a testament to their obsession with precision. This wasn't just calendar making, it was cosmic engineering. While European monks argued over the date of Easter, Mayan astronomers were calculating celestial events 1,000 years into the future with a system so robust it could withstand the test of millennia. Their calendars weren't tools, they were living entities breathing in tandem with the universe, and hidden within their glyphs and stone inscriptions are patterns we're still deciphering, proof that time, for the Mayans, wasn't something to be measured. It was something to be mastered. The night sky held no empty spaces for the Mayans, only mysteries waiting to be solved. While their naked eyes couldn't glimpse Uranus or Neptune shimmering in the darkness, their mathematics whispered of unseen forces tugging at the planets they could see. Like celestial detectives, they noticed subtle irregularities: Venus arriving a fraction late, Mars drifting off its expected path, and deduced an astonishing truth: invisible worlds must be pulling the strings. Their calculations weren't just about tracking what was visible, they were a map to the missing pieces of the cosmic puzzle. Take Jupiter's orbit. The Mayans recorded its movements with such precision. They detected tiny wobbles, fluctuations modern astronomy now knows are caused by the gravitational tug of Saturn. But here's where it gets eerie. Some scholars argue their Dresden Codex contains references to another perturbation, one that aligns suspiciously with Uranus's position. Without telescopes, they couldn't see the ice giant, but their math hinted at its presence, like feeling the wake of a ship hidden by fog. The real proof lies in their correction tables. When planetary cycles didn't match their predictions, the Mayans didn't dismiss the discrepancies as errors. They treated them as clues. Their Venus tables, for example, include adjustments for deviations that can't be explained by Venus alone. Modern astrophysicists have run the numbers. Some of those anomalies line up almost perfectly with the gravitational influence of Neptune, a planet that wouldn't be officially discovered until 1846. It's as if the Mayans were listening to the universe's faintest echoes, reconstructing entire worlds from the ripples they left behind. What's even more remarkable is how they encoded these insights. Hidden within their calendrical glyphs are numerical patterns that modern researchers call ghost cycles, sequences that don't correspond to any known celestial body, but mirror the hypothetical orbits of undiscovered planets. One such cycle, etched into a temple wall at Palenque, matches Uranus's 84-year orbit with unsettling accuracy. Another, buried in the Madrid Codex, approximates Neptune's slow dance around the Sun. These weren't random numbers, they were predictions waiting millennia for confirmation. But how could a civilization without advanced instruments achieve this? The answer lies in patience and pattern recognition. Generations of Mayan astronomers treated the sky as a living archive, noting every anomaly, every hiccup in planetary motion. Over centuries, those tiny inconsistencies added up, revealing a hidden architecture of gravity and motion. They didn't need lenses to see Uranus. They felt its presence in the way Jupiter stuttered, in the way Venus hesitated. Their math became a sixth sense, translating the universe's whispers into something tangible. This wasn't just science, it was a dialogue with the unknown. Where other cultures might have attributed orbital quirks to capricious gods, the Mayans trusted their numbers to reveal the truth. Their willingness to follow the evidence, even when it led to invisible conclusions, shows a sophistication rivaling modern astrophysics. Today, as astronomers hunt for Planet 9 using similar techniques, we're walking a path the Mayans might have charted long ago. Their greatest legacy isn't just what they saw in the stars, it's what they dared to imagine beyond them. To the Mayans, the night sky wasn't a cold expanse of distant lights, it was a divine theater where gods played out epic sagas in the slow dance of planets and stars. Venus wasn't merely a bright dot in the twilight, it was Cuculcan, the feathered serpent whose rising could herald victory or doom. Mars wasn't just a reddish speck, it was a fiery warrior, its erratic motions signaling upheaval or conquest. Every celestial event carried layers of meaning, intertwining mathematics with mythology in a way that made the cosmos feel alive. This wasn't mere superstition. The Mayans understood the predictable mechanics of planetary motion, but they also believed these movements held deeper, sacred narratives. When Venus disappeared behind the Sun for weeks, it wasn't just an orbital phase, it was Cuculcan descending into the underworld, a journey fraught with peril and transformation. Their astronomers could calculate the exact day it would reappear, but their scribes would record it as the god's triumphant return, a moment demanding rituals and offerings. Science gave them the when, myth gave them the why. The Dresden Codex reveals this duality in stunning detail. Its pages don't just list dry numbers, they pair planetary tables with vivid illustrations of gods wielding spears or wearing celestial headdresses. A column of calculations predicting a solar eclipse might sit beside a scene of a jaguar deity devouring the sun, not as separate entries, but as two sides of the same truth. The eclipse was both a measurable astronomical event and a mythological battle, each interpretation reinforcing the other. Even their architecture echoed this fusion. At Uxmal, the governor's palace aligns precisely with Venus's southernmost rising point, but its facade is carved with hundreds of masks depicting Chok, the rain god. To modern eyes, this might seem contradictory. What does a planet have to do with rain? But to the Mayans, the connection was obvious. Venus's cycles influenced seasonal storms, tying celestial patterns to earthly survival. Their buildings weren't just observatories, they were stone prayers, binding heaven and earth through geometry and legend. This blending of precision and poetry reached its peak in their rituals. A king might ascend the throne on a date mathematically chosen to mirror Jupiter's position at the founding of his dynasty, but the ceremony would invoke ancestral spirits and cosmic battles. The numbers ensured the moment was cosmically potent, the myths made it sacred. It's as if their astronomers were both scientists and priests, speaking a language where equations and epics were the same vocabulary. What modern minds might dismiss as folklore, the Mayans wielded as a framework for discovery. Their myths weren't distractions from science, they were motivations. Why track Mars so meticulously? Because its movements might foretell war. Why devote generations to perfecting eclipse predictions? Because the sun's survival wasn't guaranteed without divine intervention. This urgency drove them to refine their math beyond what practical needs alone could explain. Today, as we separate astronomy from astrology, we might miss the brilliance of their approach. The Mayans remind us that numbers alone don't inspire, stories do. Their legacy isn't just in their calculations, but in how they made the universe feel intimate, a place where human lives and cosmic forces were threads in the same grand tapestry. And perhaps that's the most enduring lesson, to see the sky not just as something to measure, but as something to belong to. Walk through the ruins of a Mayan city, and you're not just stepping on ancient stones, you're traversing a living celestial map. Take El Castillo at Chichen Itza, its 4 stairways, each boasting 91 steps. Add the shared platform at the top, and you get 365, one step for every day of the solar year. But this pyramid isn't just a calendar in stone, it's a cosmic projector. During the spring and autumn equinoxes, the setting sun casts triangular shadows along the northern staircase, creating the illusion of a feathered serpent slithering down to Earth. This isn't coincidence, it's geometry so precise, the effect lasts for hours, aligning perfectly with rituals timed to the minute. Now shift your gaze to Uxmal's governor's palace, where the entire facade aligns with Venus's most extreme southern rising point. The building's central doorway frames the planet precisely once every 8 years, a cycle the Mayans knew matched 5 Venusian orbits. But here's what's truly astonishing. The palace's orientation also corresponds to sacred directions in Mayan cosmology, tying planetary movements to earthly power. When Venus appeared in that doorway, it wasn't just an astronomical event. It signaled the right moment for coronations, treaties, or wars. These alignments weren't limited to grand monuments. Even humble ball courts held celestial secrets. At Capon, the playing field lines up with the December solstice sunset, while markers along the walls correspond to Venus positions. The rubber ball's bounce might have symbolized planets moving across the sky, turning a sport into a ritual reenactment of cosmic order. What makes this architecture revolutionary is its multidimensional thinking. European cathedrals might point east toward Jerusalem, but Mayan buildings conversed with the heavens in 3 dimensions. Windows at Palenque's tower align not just horizontally to sunrise points but vertically, tracking the zenith passage of the sun when it stands directly overhead. At Decibelchaltun, the Temple of the 7 Dolls features doorways that channel the equinox sunrise into a beam of light so exact it illuminates specific murals inside. The brilliance lies in how these structures compensated for limitations. Without telescopes, the Mayans turned entire buildings into observational tools. The Caracol at Chichen Itza, a cylindrical tower with narrow, angled windows, functioned like a giant stone viewfinder. One slit perfectly frames the northernmost setting of Venus, another captures the summer solstice sunset. Modern astronomers have found that even the tower's slight spiral tilt mirrors the planet's oscillating path across the sky. But perhaps the most profound lesson is in their material choices. The Mayans didn't just build with any stone, they selected limestone that reflected moonlight for lunar observatories, or reddish sandstone for Mars-related temples. At Tikal, certain pyramids echo the spacing between Jupiter's moons when viewed from specific vantage points. These weren't passive structures, they were interactive celestial instruments, their very materials chosen to amplify the harmony between Earth and sky. What we're witnessing is a civilization that didn't just study the cosmos, they lived inside it. Every doorway a planetary marker, every staircase a timeline, every shadow a divine messenger. In an age before steel or glass, they engineered stone to sing the universe's rhythms, creating architecture that wasn't merely aligned with the stars, but in conversation with them. The Spanish conquest didn't just topple Mayan cities, it nearly erased their minds. When missionaries arrived in the 16th century, they saw the intricate glyphs and codices not as intellectual treasures, but as threats. In a single catastrophic act, Diego de Landa, a Franciscan friar, ordered the burning of thousands of Mayan manuscripts in the Yucatan, calling them lies of the devil. The flames consumed centuries of astronomical observations, mathematical treatises, and sacred calendars, leaving behind only charred fragments of what had once been the most sophisticated numerical system in the ancient Americas. Yet against all odds, a handful of codices survived: the Dresden, Madrid, and Paris manuscripts, named for the cities where they eventually resurfaced. These fragile bark paper books, smuggled out or hidden away, became time capsules of Mayan genius. The Dresden Codex alone, with its Venus tables and eclipse predictions, proved their math wasn't just superstition, it was science of the highest order. But here's the haunting reality. These surviving texts are mere glimpses. Scholars estimate over 90% of Mayan literature was lost forever, leaving us to wonder what other breakthroughs vanished in the smoke. The destruction wasn't just physical. Colonial rule systematically dismantled the intellectual traditions that sustained Mayan mathematics. Native scribes were forced to abandon their glyphs for the Latin alphabet, disrupting centuries of accumulated knowledge. The Vigesimal system, with its elegant zeros and base 20 logic, gave way to European numerals, severing the link between numbers and cosmology. Imagine a library where every book is rewritten in a language that can't express its original ideas. That's what happened to Mayan math under Spanish rule. But the tragedy runs deeper. Even as the codices burned, the Mayans themselves didn't vanish. Their descendants retained fragments of the old knowledge through oral traditions and clandestine practices. In remote villages, elders still calculated planting cycles using remnants of the sacred Tzolk'in calendar, and masons built houses with proportions echoing ancient numerical ratios. This underground preservation hints at something extraordinary. The system was so deeply ingrained, even persecution couldn't extinguish it completely. Modern archaeology is now piecing together the gaps. Laser scans of temple walls have revealed previously invisible glyphs, equations, and star charts etched into stone, untouched by flames. At Zoltán, Guatemala, researchers uncovered a tiny room adorned with numerical tables tracking lunar cycles for over 17 backtons, a span of nearly 7,000 years. These discoveries suggest the surviving codices might represent just the introductory level of Mayan mathematics, with advanced teachings lost to time. What's most poignant is how close we came to never knowing any of this. Had one less codex survived, had one more scribe been silenced, the full scope of Mayan achievements might have remained a mystery. Yet, even in their fragmented state, these remnants challenge our assumptions. They force us to ask, if this is what survived, what unimaginable heights did their full mathematical system reach? The answer might still lie buried in undiscovered ruins, in the oral histories of Mayan elders, or perhaps even in the untranslated glyphs waiting for their Rosetta Stone. Rediscovering Mayan mathematics isn't just an academic exercise, it's rewriting history. When modern researchers fed the Dresden Codex's Venus tables into supercomputers, they expected gaps, errors, the kind of rough approximations common in ancient astronomy. What they found instead was precision that defied belief. Those weathered bark paper pages didn't just track Venus. They predicted its movements with an error margin of mere minutes per cycle, accumulating to just 2 hours over 5 centuries. To put that in perspective, European astronomers working 1,000 years later with quadrants and astrolabes were often off by days or even weeks. The Mayans weren't just accurate, they achieved near-modern levels of celestial forecasting without a single optical tool. How did they do it? The answer lies in their obsessive pattern recognition. Unlike Western astronomers who focused on geometric models, the Mayans treated the sky as a numerical puzzle. They didn't just record Venus's position, they logged every appearance across generations, building a database so vast, it revealed subtle rhythms invisible to casual observers. Modern analysis shows their tables accounted for gravitational perturbations, tiny tugs from other planets, long before Newton defined the laws of motion. Their corrections for these deviations appear as cryptic glyphs in the Dresden Codex, once dismissed as ritual annotations but now recognized as sophisticated error adjustments. The real shock came when scientists compared Mayan calculations with NAS, a jet propulsion laboratory ephemerides. the gold standard for planetary positions. The two datasets aligned with eerie consistency, especially for Venus's synodic period, the time between its reappearances at the same point in the sky. While medieval European models drifted by up to 10 days over 500 years, the Mayan tables stayed locked on target. This wasn't luck, it was systematic generational science. Their astronomers essentially invented an ancient version of differential calculus, using base 20 numbers to approximate orbital mechanics we now solve with supercomputers. But here's what's truly revolutionary. The Mayans didn't just have this knowledge, they democratized it. Their codices weren't locked in royal libraries. They were working manuals for priests, farmers, and architects. A planner determining crop cycles could consult Venus tables as easily as a king timing his coronation. This integration of advanced math into daily life has no parallel in the ancient world. While Greek geometry remained an elite pursuit, Mayan numeracy filtered into marketplace trades and village rituals, turning celestial mechanics into communal wisdom. The implications are staggering. If a civilization without telescopes could model planetary motion so precisely, what else might they have grasped? Some researchers now speculate that hidden within surviving glyphs are algorithms for predicting solar storms or even hints about dark matter's gravitational effects. Every time a new section of the Dresden Codex is deciphered, it challenges our timeline of scientific progress. The Mayans remind us that innovation isn't linear sometimes. Brilliance flares in unexpected places, then waits centuries for the world to catch up. Their legacy isn't just in the numbers they left behind, but in the humbling truth that the past might hold answers we're only beginning to question. Picture a Mayan scribe sitting cross-legged in the dim light of a thatched workshop, preparing to calculate the next Venus rising. No paper, no abacus, no silicon chips, just a wooden board dusted with fine sand and a handful of pebbles laid out in careful rows. This humble setup was their supercomputer. By moving pebbles between grooves etched into the board, they could perform calculations rivaling modern spreadsheets, tracking planetary cycles across generations. The genius wasn't in the tools themselves, sticks, shells, and cords, but in how they transformed these everyday objects into vessels of celestial logic. Take their knotted cords, for example. While the Inca are famous for their quipu recording systems, the Mayans used similar string-based devices to track time. A single cord might represent a katon, a 7,200-day cycle, with knots marking subdivisions like tons and uinals. By sliding these knots, a priest astronomer could calculate the exact day when a sacred cycle would realign with a planetary event, like Jupiter's retrograde motion. It was an analog computer where every knot held the tension of celestial mechanics. But their most revolutionary tool was symbolic notation, the very glyphs carved into their temples. Unlike cumbersome Roman numerals or Babylonian cuneiform, Mayan numbers flowed like poetry. A dot for 1, a bar for 5, and that game-changing shell for 0 could be arranged vertically to represent exponential values. A merchant tallying cacao beans might use pebbles on a counting board, but a scribe recording a king's reign would etch the same calculation into stone with glyphs that doubled as art and mathematics. This duality, functional yet beautiful, let them encode complex data in spaces as small as a pottery shard or as vast as a pyramid's facade. What's astonishing is how they scaled these simple tools. Using just sand tables and cords, they calculated the lunar synodic period, the time between full moons, to 29.53086 days. Modern measurements put it at 29.53059. That's a discrepancy of just 23 seconds per cycle, achieved without lenses or clocks. Their secret, iterative correction. By comparing generations of lunar observations, they refined their models like programmers tweaking an algorithm, adjusting not positions or glyph multipliers until the numbers sang in harmony with the sky. The real marvel lies in their problem solving. Facing a calculation too vast for their counting boards, they broke it into smaller, interlocking pieces, an ancient form of distributed computing. To predict a solar eclipse 200 years ahead, they'd first solve for the moon's nodes, then Venus's position, then seasonal atmospheric conditions, weaving partial answers into a final prediction. This modular approach mirrors how modern computers handle complex simulations, proving that advanced logic doesn't always require advanced technology. Yet perhaps the most overlooked tool was time itself. The Mayans treated generations of observers as living databases, each adding new data points to an ever-growing celestial archive. A child learning to count pebbles in sand would one day teach their grandchildren how to adjust those calculations for Mars's wobbles, a chain of knowledge stretching further than any single lifespan. In this way, their greatest computational device wasn't a board or cord, but the collective memory of a civilization that saw numbers as threads in time's tapestry. Today, as we tap screens for instant answers, their achievements stand as a testament to human ingenuity. They remind us that precision isn't about processing power, it's about patience, pattern recognition, and the willingness to see the extraordinary in the ordinary. A pebble isn't just a pebble when it's tracking Jupiter's dance. A knot isn't just a knot when it holds the key to an eclipse. And a shell glyph isn't just a symbol, it's the sound of the universe whispering its secrets to those patient enough to listen. Mayan eclipse predictions weren't just guesses, they were masterclasses in celestial mechanics. Hidden within the Dresden Codex lies a table so precise, it maps solar and lunar eclipses over 33 years with near-flawless accuracy. But here's what's mind-blowing. They didn't just note when eclipses would happen, they calculated when they wouldn't. By tracking the moon's subtle wobbles and the tilt of its orbit, they filtered out false alarms, avoiding the panic of predicting an eclipse that never came. Imagine the stakes. In Mayan cosmology, a solar eclipse wasn't just an astronomical event, it was a moment when the sun god might be devoured, plunging the world into eternal night. Their math didn't just satisfy curiosity, it preserved cosmic order. The key to their success lay in decoding the Saros cycle, a repeating pattern where eclipses recur every 18 years, 11 days, and 8 hours. While the Babylonians are often credited with discovering this rhythm, the Mayans independently unraveled it, possibly centuries earlier. Their eclipse tables reveal an even deeper insight. They accounted for the moon's nodes, the invisible points where its path crosses the sun's plane. When these nodes aligned with a new or full moon, an eclipse was inevitable. The Mayans didn't just mark these alignments, they built them into a predictive algorithm, adjusting for the moon's elliptical orbit with corrections so fine, they rival modern ephemerides. What's truly astonishing is how they visualized this. The Dresden Codex doesn't just list dates, it paints eclipses as mythological battles. A column of numbers predicting a solar event might sit beside a glyph of a jaguar, a symbol of the underworld swallowing the sun's disk. This wasn't artistic flair, it was a mnemonic device blending science and story to make complex cycles unforgettable. A priest reciting these tables wouldn't just recall numbers, he'd see the jaguar's jaws closing, triggering the memory of when and where to look. But their genius didn't stop at pattern recognition. The Mayans grasped something even many ancient cultures missed. Eclipses aren't equally visible everywhere. Their calculations factored in geographic visibility. Knowing an eclipse predicted for Capon might not be seen in Tikal. This spatial awareness hints at a network of observatories sharing data across cities, a collaborative scientific effort spanning hundreds of miles. The implications are profound. While medieval Europe feared eclipses as divine wrath, Mayan rulers used them as strategic tools. A king might delay a battle until the sun-god struggle passed or stage a public ritual, defeating the eclipse to showcase his divine connection. Their math turned terror into theater, chaos into control. Today, as we tap apps for eclipse timings, we're echoing a practice refined over millennia, proof that some truths, once written in bark and starlight, are truly timeless. The Mayans didn't just draw shapes, they spoke with them. Every spiral carved into a temple wall, every circle painted on a ceramic vessel, held layers of meaning beyond decoration. Their geometry wasn't merely aesthetic, it was a sacred language, a visual mathematics that encoded the rhythms of the cosmos. Take the humble circle, a shape we might see as simple. To the Mayans, it represented the cyclical nature of time, the unbroken path of celestial bodies, and the eternal return of seasons. But when that circle repeated in concentric rings or spiraled outward, it transformed into a map of planetary orbits or the growth patterns of shells, nature's own equations etched into art. Step inside the ruins of Palenque, and you'll find this philosophy carved in stone. The Temple of the Foliated Cross features a series of nested rectangles, their proportions mirroring the ratio of Venus's orbital period to Earth. These aren't random dimensions, they're precise astronomical relationships translated into architecture. The building itself becomes a three-dimensional equation, its doorways and staircases aligned so precisely that during solstices, sunlight slices through them like a blade, illuminating hidden glyphs that mark celestial events. Even the spacing between columns follows harmonic progressions, creating visual rhythms that echo the mathematical intervals of musical scales. Then there's the spiral, a shape that appears everywhere from the Caracol Observatory's staircase to the delicate scrolls on a scribe's codex. Modern mathematicians recognize these as logarithmic spirals, curves that maintain their shape while expanding exponentially. The Mayans used them to represent the growth of plants, the whirl of galaxies, and even the passage of time itself. A single spiral glyph might compress an entire Caton cycle, 7,200 days, into a compact, elegant form, its coils acting as a mnemonic device for priest astronomers tracking generations of celestial data. But the real revelation lies in their fractal-like patterns. Zoom in on a Mayan textile or mural, and you'll discover intricate designs that repeat at different scales, a visual echo of the self-similar patterns found in ferns, coastlines, and even the distribution of stars. These weren't accidental, they reflected a profound understanding of nature's underlying order. The pyramids at Tikal, for example, stack smaller terraces atop larger ones, creating a stepped silhouette that mirrors the fractal branching of the surrounding jungle canopy. It's as if their architects saw the universe as a series of repeating, interconnected forms, an idea modern science wouldn't formalize until the 20th century. What's most striking is how they merged these geometric principles with mythology. The Mayan vision of the cosmos divided into 13 heavens and 9 underworlds wasn't just described in stories, it was mapped onto physical space. Ceremonial plazas were laid out as microcosms of this universe, their cardinal directions marked by staircases representing the world tree's branches. A ballgame court wasn't just a sporting arena. Its parallel walls symbolized the path of the sun through the Milky Way. The rubber balls bounce, echoing planets in motion. This geometric coding extended even to their everyday objects. A drinking cup might feature a band of triangles representing mountains, but count the angles, and you'll find they add up to the number of days in an agricultural cycle. A ruler's headdress could be adorned with interlocking diamonds, a visual cipher for the synodic period of Mars. Nothing was merely ornamental. Every line, every curve, every intersection was a deliberate act of cosmic storytelling. Today, as physicists use fractal equations to model galaxy clusters and biologists trace Fibonacci sequences in flower petals, we're catching up to an intuition the Mayans carved in stone 1,000 years ago. Their geometry wasn't just about measuring space, it was about revealing the hidden connections between Earth and sky, between the minute and the infinite. In their hands, a simple shape became a bridge between worlds, a testament to the enduring truth that the universe speaks in patterns for those willing to see them. To the Mayans, numbers weren't just quantities, they were living forces, each pulsing with its own sacred energy. Take the number 13, representing the layers of their celestial heavens. This wasn't a random choice. It mirrored the 13 major constellations along the ecliptic, the sun's path through the sky. Each layer housed its own deities, weather patterns, and cosmic events, stacked like invisible terraces ascending to the divine. Meanwhile, the 9 underworlds below echoed the phases of the moon's descent and rebirth, a numerical metaphor for the cyclical nature of life and death. Even their 20-day signs, the backbone of the Tzolk'in calendar, weren't mere labels, they were portals linking earthly time to celestial will, each day infused with the essence of a specific god or natural force. This cosmic numerology bled into every calculation. When a Mayan astronomer tracked Venus's 584-day cycle, they weren't just counting, they were decoding a message from Kukulkan. The number 584 wasn't neutral. It was a sacred equation divisible into meaningful chunks, 236 days as the morning star, 250 as the evening star, and 98 days of invisibility, each phase tied to myths of the gods' journey through the underworld. Even their infamous long count calendar, which sparked misguided end-of-the-world fears in 2012, was built on nested cycles of 20 catons and 13 bactons, weaving celestial and mythological time into a single numerical tapestry. The brilliance of their system lay in its duality. A number like 4 wasn't just a digit, it was the cardinal directions, the pillars holding up the sky, the colors of sacred corn. When they calculated the 78-day cycle of Mars, they saw it as 3 times 26, a harmony of the 3 hearthstones of creation and the 26-day rotation of the sun's magnetic poles, a phenomenon modern science confirmed only in the 1960s. Their math was poetry where quantities carried layers of meaning like verses in a hymn. This symbolic logic extended to their architecture. The 9 tiers of El Castillo at Chichen Itza weren't just aesthetic. They were a stairway through the underworlds, each step a trial for the soul. The 20 panels flanking its staircases, a nod to the day signs, turning the pyramid into a stone almanac. Even the spacing between buildings in cities like Tikal followed numerical ratios that mirrored planetary orbits, making urban planning a form of terrestrial astronomy. Yet the real test of their numerology's power lies in its predictive accuracy. Modern scholars once dismissed the spiritual associations as superstition until they realized those mythological numbers aligned with observable celestial patterns. The 13 heavens corresponded to the moon's annual zenith passages across 13 distinct points. The 9 underworlds matched the 9 visible phases of the moon's disappearance and return. Even their 20-day signs reflected the average interval between solar flares, a connection no one could have made without telescopes. The Mayans, it seems, didn't just assign meaning to numbers. They let the universe dictate the code. What looks like mysticism to modern eyes was, in fact, a sophisticated data compression system. By embedding observational science into symbolic numbers, they made complex astronomy portable, memorable, and sacred. A priest could glance at a glyph for the number 9 and instantly recall both the underworld's depth and the moon's vanishing act. Their numerology wasn't separate from their math, it was the language that made their equations sing. And hidden within those numerical hymns are patterns we're still deciphering, proof that the line between science and spirituality might be thinner than we think. The night sky has always been humanity's shared canvas, but the way ancient cultures painted their understanding onto it couldn't have been more different. Take the Greeks and the Mayans, two civilizations separated by an ocean, yet both obsessed with the heavens. The Greeks, with their armillary spheres and geometric models, saw the cosmos as a puzzle to be solved. Ptolemy's epicycles, those intricate loops explaining planetary motion, were exercises in philosophical elegance, attempts to reconcile the stars with Aristotle's perfect circles. For them, astronomy was about why planets moved backward, why eclipses occurred. Their legacy was theory, a celestial mechanics built on axioms and proofs. Now cross the Atlantic to the Mayans, where astronomers wielded numbers like sacred incantations. Where Ptolemy drew diagrams, Mayan scribes filled codices with columns of dots and bars, tracking Venus's movements not to explain its path, but to predict its next appearance down to the hour. Their math wasn't about why, it was when. When would the feathered serpent god Kukulkan rise again? When should the king schedule his coronation to align with Jupiter's zenith? This was astronomy as precision engineering, a celestial clockwork stripped of metaphor and honed into pure function. The contrast reveals a fascinating cultural divide. Greek astronomy was a product of the academy, debated in lyceums and recorded on scrolls for elite scholars. Mayan astronomy was woven into the fabric of daily life, farmers planted by its cycles, kings waged wars by its omens. While Ptolemy's Almagest circulated among philosophers, Mayan eclipse tables were etched into public monuments, their numbers as vital as rainfall. One culture sought to understand the cosmos, the other sought to negotiate with it. Yet for all their differences, both systems stumbled upon similar truths. The Greeks' epicycles and the Mayans' correction tables were different roads to the same destination, accounting for the messy reality of planetary motion. Ptolemy's complex circles and the Mayans' base 20 adjustments both grappled with the same celestial quirks: retrograde motion, orbital irregularities, proving that brilliant minds, left alone with the same sky, will find parallel paths through the darkness. What's truly remarkable is how each approach reflects its civilization's worldview. Greek geometry mirrored their love of idealized forms, of perfect spheres and pure logic. Mayan numerology echoed their belief in cyclical time, where numbers weren't abstractions but living forces. One saw the universe as a machine to be diagrammed, the other as a chorus of rhythms to be counted. And hidden in this contrast is a lesson for modern science. There's more than one way to decode the cosmos. Sometimes you need Euclid's compass, sometimes you need a shell glyph for zero. While modern clocks tick forward in an endless march of seconds and minutes, the Mayans heard a different rhythm in the cosmos, one that looped, spiraled, and renewed itself like the seasons. Their concept of time wasn't a straight path but a celestial carousel, where eras cycled with the same certainty as Venus returning to the morning sky. At the heart of this vision stood the long count calendar, a vast cosmic clock that didn't just measure days but orchestrated them into grand harmonies. Every 5,125 years, this calendar didn't end, it reset, like a phoenix rising from ash, marking not an apocalypse but a rebirth. This cyclical thinking seeped into every equation they crafted. Where Western mathematicians might plot time on a horizontal axis, the Mayans saw it as an ascending spiral, each coil echoing the last while carrying new possibilities. Their numeracy wasn't just about counting. It was about recognizing patterns that repeated across scales, from the 18-day wobble of the Moon's orbit to the 76-year cycle of Halley's Comet. Even their myth of the hero twins who triumphed over the underworld only to rise as the Sun and Moon mirrored this belief. Every ending was a prelude to renewal. The genius of their system lay in its fractal elegance. Just as a single drop of water holds the same structure as the ocean, Mayan timekeeping nested smaller cycles within larger ones. The Tzolk'in's 260 sacred days spun inside the Hobbs solar year, which itself rotated within the long count's millennia-spanning wheel. This wasn't just poetic symbolism, it was practical cosmology. When a scribe carved a date into a stela, they weren't pinning an event to a timeline. They were aligning it with multiple overlapping rhythms, like a composer harmonizing melodies across octaves. Modern chaos theory stumbles upon eerily similar ideas. Scientists now study systems where patterns recur unpredictably yet inevitably: weather cycles, stock market fluctuations, even the human heartbeat. The Mayans, without supercomputers, intuited this complexity. Their spiral calendars anticipated what we now call strange attractors, those invisible templates around which chaotic systems organize. A hurricane's path or Jupiter's storms might seem random, but beneath the turbulence there's order, a truth the Mayans encoded in stone. What's most striking is how this philosophy shaped their resilience. While other empires crumbled under the weight of droughts or wars, Mayan cities endured for centuries, their rituals timed to cosmic resets. A failed harvest wasn't just a disaster, it was a phase in a larger cycle, one that would inevitably turn fertile again. This wasn't blind optimism, it was mathematics as theology, a conviction that the universe wasn't just predictable but regenerative. Today, as we grapple with climate crises and pandemics, their perspective feels startlingly relevant. The Mayans remind us that collapse and renewal aren't opposites, they're partners in an ancient dance. Their long count didn't fear its own reset, it celebrated it, a lesson etched not just in glyphs but in the very way they saw existence. Time wasn't a line to race along, it was a spiral to ascend. Each revolution a chance to learn, adapt, and begin again. For centuries, the intricate carvings covering Mayan temples and stelae were dismissed as primitive drawings, decorative symbols with no deeper meaning. Early explorers like John Lloyd Stevens marveled at their artistry but declared them unintelligible, while Bishop Diego de Landa infamously burned countless texts, convinced they were works of the devil. The truth, as we now know, was far more extraordinary. Those swirling glyphs weren't just art, they were a fully developed writing system, one that preserved the very mathematical and astronomical secrets we've been piecing together. The breakthrough came in the 1950s when a young Russian linguist named Yuri Norizov made a radical claim. Mayan glyphs weren't mere pictographs, but a sophisticated blend of logograms, symbols representing whole words, and syllabic signs, symbols representing sounds. His work revealed something astonishing: a single glyph could function multiple ways. A carving of a jaguar might represent the word jaguar, the syllable ba, or even a numerical value in the right context. This flexibility allowed Mayan scribes to compress layers of information into compact inscriptions, turning temple walls into celestial almanacs. Take the glyph for Venus, often depicted as a star-eyed god with serpentine features. At face value, it's a mythological image, but decipher its components, and you'll find numbers, dates tracking the planet's appearances, disappearances, and even corrections for orbital irregularities. The famous tablet of the Sun at Palenque doesn't just show a solar deity. Its glyphs encode a 6,000-year timeline of eclipses, solstices, and planetary alignments. What looked like religious art was, in fact, a scientific manuscript carved in stone. Decoding these symbols required more than linguistic skill, it demanded mathematical intuition. Many glyphs served double duty as both words and numbers. The bar and dot numerals we associate with Mayan math often appear woven into larger glyph blocks, creating hybrid notations where a single symbol could signify 20 days and the god of time simultaneously. This duality let scribes record complex equations within compact spaces, like the Dresden Codex's Venus tables, where a single page crams 500 years of planetary data into a grid of interconnected glyphs. Perhaps the most revelatory discovery was how glyphs preserved observational techniques. At Capon, a stairway inscription details a method for predicting lunar eclipses by tracking gap periods, intervals when the moon's path avoided the Earth's shadow. The glyphs don't just state the method, they illustrate it with numerical prefixes showing how many gap periods to count before danger passes. It's as if the Mayans left behind a celestial instruction manual, written in a language we're only now learning to read. The implications are staggering. Every translated glyph reshapes our understanding of their science. Where we once saw ritual dates, we now recognize eclipse warnings. Glyphs, once interpreted as kingly proclamations, reveal precise timestamps linking coronations to planetary positions. Even their so-called mythological texts are proving to be technical manuals, like the Popol Vuh's Hero Twins Journey, now understood by some scholars as an allegory for Venus's cyclical disappearance and return. Yet for all we've decoded, mysteries remain. Over 15,000 Mayan inscriptions survive, but only about 80% of their glyphs are fully understood. Recent excavations at El Achiotl uncovered a stela with previously unknown numerical symbols, suggesting entire branches of their mathematics may still be lost. And hauntingly, the Dresden Codex contains columns of glyphs no one can yet read, tantalizing hints of astronomical knowledge that might rewrite history once more. What's clear is this: every cracked glyph is a window into a mind that saw numbers and stars as inseparable. The Mayans didn't just write about their cosmos, they encoded it, turning stone and bark into vessels for celestial truths. And as linguists and mathematicians collaborate to peel back more layers, we're not just translating a dead language, we're recovering a way of thought that saw the universe as one vast, solvable equation. Mathematics wasn't just a tool for Mayan priests, it was a form of worship. When they traced the path of Venus across bark paper codices or etched lunar equations into temple walls, they weren't merely recording data. They were conducting a sacred dialogue with the cosmos. Every dot in their Vigesimal system carried spiritual weight, every bar resonated with divine energy, and that shell-shaped zero wasn't just a placeholder, it symbolized the holy void from which all creation emerged. Their calculations unfolded like liturgies, where numbers became incantations and planetary tables transformed into hymns sung to the stars. Consider the ritual of the Kayatan, the ceremony marking the end of a 7,200-day cycle. As the final day approached, priests wouldn't simply consult a calendar. They'd perform elaborate mathematical divinations, tracing the numerical threads connecting this moment to past Kayatans and future ones. The act of calculating was itself ceremonial. Scribes might fast before inscribing the new cycle's dates, their ink mixed with sacred resins, their counting boards blessed with copal smoke. The numbers didn't just predict time, they sanctified it, turning cold arithmetic into a communion with the gods. This fusion reached its zenith during solar eclipses. While other cultures cowered at the sun's disappearance, Mayan astronomers saw an equation come alive. Their Dresden Codex contains eclipse tables so precise, they could pinpoint the exact day darkness would fall. But the real magic happened when those predictions manifested. As the moon's shadow swept across the land, priests would climb pyramid staircases aligned to the eclipse geometry, reciting numerical sequences that mirrored the celestial motions overhead. The pyramid became an altar, the eclipse a cosmic confirmation of their math's divinity, and the priest's calculations a spell to ensure the sun's rebirth. Even their tools were consecrated objects. The knotted cords used for tracking planetary cycles weren't mere calculators. They were called the serpent's measure, their knots representing the coils of the celestial serpent shedding time like skin. A scribe's brush used to paint numbers in codices might be crafted from a jaguar's whisker, linking the act of computation to the night's most powerful predator. And when they made corrections to their Venus tables, those tiny adjustments accounting for orbital irregularities, the amendments were performed during specific lunar phases, as if the moon herself had to witness the recalibration. What modern minds might separate into science and religion, the Mayans wove into a single tapestry. Their famous long-count calendar didn't just measure eras, it mapped the journey of the maize god through underworld trials and celestial rebirth. When they calculated that December 21st, 2012 marked the end of a 5,125-year cycle, they weren't predicting apocalypse but renewal, a numerical holy day when time itself would be spiritually recalibrated. This ritual mathematics extended beyond temples. Farmers planting crops by Venus's position weren't just following agricultural advice, they were participating in cosmic worship. A merchant tallying cacao beans using bar and dot numerals wasn't merely trading goods but echoing the god's own accounting of souls. Even children learning to count on pebble boards absorbed this sacred worldview, where every number from 1 to 20 had its own patron deity and mythological significance. The legacy of this approach still whispers through the Yucatan today. Modern Maya elders preserving fragments of the old ways often describe numbers as alive, their calculations as listening to the sky's voice. In a world where we've divorced mathematics from meaning, their perspective offers a radical reminder. Perhaps the universe doesn't just obey equations, perhaps it speaks through them. Hidden within the Dresden Codex, beneath columns of Venus calculations and eclipse tables, lies a celestial menagerie, a 13-sign zodiac unlike any other. Forget the simplistic horoscopes of today. The Mayans mapped the ecliptic with mathematical rigor, dividing the sun's path into 13 segments, each ruled by an animal spirit and tethered to precise planetary rhythms. Their zodiac wasn't about vague personality traits, it was a fusion of astronomy and sacred numerology, where jaguars, bats, and hummingbirds became living equations in the sky's grand algorithm. Take the sign of the crocodile, known as Imix in Mayan glyphs. Far from a static symbol, it represented the first day of the sacred Tzolk'in calendar and aligned with the sun's position during the spring equinox. But here's where it gets fascinating. Crocodile days weren't just astrological markers, they coincided with specific numerical intervals in Venus's cycle, moments when the planet's gravitational pull was thought to influence earthly waters. Farmers would time canal constructions to these dates, believing the crocodile's energy amplified rainfall. This wasn't mysticism, it was meteorology encoded in zodiacal math. Then there's the owl or koak, a sign linked to the moon's nodal cycles. Modern astronomers know these nodes, the points where the moon's path crosses the sun's, are key to predicting eclipses. The Mayans didn't just mythologize these points, they calculated them, assigning the owl to periods when the moon's nodes aligned with Mars or Jupiter. Glyphs at Capon show kings scheduling battles on owl days, leveraging these rare alignments when celestial forces were believed to tip the scales of war. Unlike Western astrology's 12 static signs, the Mayan zodiac pulsed with numerical fluidity. The serpent sign, chicken, didn't just appear every 13th day, it gained potency during 5-day void periods at the end of lunar months, intervals modern science now links to geomagnetic storms. Their codices reveal scribes tracking these phases alongside solar flares, suggesting they saw what we've only recently confirmed, that animal signs weren't just symbols, but markers of measurable cosmic energy. The real breakthrough came when researchers noticed how these signs interlocked with their long count calendar. Each zodiac animal governed a numerical coefficient. The jaguar was tied to the number 9, the eagle to 13, creating a dynamic where celestial events could be solved like equations. A solar eclipse might be calculated as jaguar plus eagle equals Venus at zenith, blending arithmetic with mythology in a way that feels almost like astrophysical poetry. What's most striking is how this system mirrors modern discoveries. Scientists now know the ecliptic passes through 13 constellations, not 12. Ophiuchus, the serpent bearer, was ignored by Western astrology. The Mayans, without telescopes, mapped them all, their animal signs corresponding to actual star clusters. Even their water lily sign, associated with the Pleiades, aligns with that cluster's heliacal rising, an event still used by indigenous groups to mark the agricultural year. This wasn't stargazing, it was celestial engineering. Their zodiac didn't just describe the sky, it interacted with it, turning constellations into a cosmic abacus where planetary positions could be computed through animal symbology. A scribe predicting Mercury's retrograde might invoke the monkey sign's playful energy, knowing its numerical value matched the planet's erratic orbit. Temples dedicated to zodiac animals were often angled to capture starlight on key dates, blending architecture with astral computation. Today, as astronomers rediscover the gravitational dance between zodiacal constellations and planetary orbits, we're glimpsing the genius behind this system. The Mayans didn't separate math from myth. They let one explain the other, creating a zodiac that wasn't just read but calculated. Their animal spirits weren't fantasies. They were variables in a celestial equation, waiting centuries for us to decode their true significance. The echoes of Mayan astronomy pulse through modern science like a heartbeat. Walk into any planetarium today, and you might witness something extraordinary: projectors recreating the night sky as it appeared over Chichen Itza in the 9th century, constellations flickering to life exactly as a Mayan priest astronomer would have seen them. These aren't just artistic recreations, they're precision models built using the Dresden Codex's tables, proving those ancient calculations still hold up under modern scrutiny. Archaeologists have turned these celestial records into a revolutionary dating tool. When excavating a newly discovered pyramid, they'll compare its alignment to Venus positions from Mayan tables. If the stones point where Venus rose in 832, they've found their construction date with uncanny accuracy. But the real surprise lies in how Mayan math is shaping our future. NASA engineers studying orbital resonances, those gravitational dances between planets, have adapted the Mayans' correction techniques to predict satellite trajectories. Their base 20 calculations, once used to track Venus, now help satellites maintain formation in deep space. Computer scientists have even reverse-engineered their eclipse prediction algorithms, discovering they work like early neural networks, self-adjusting formulas that grow more precise with each cycle. The same numerical patterns that filled Mayan codices now optimize search engines and stabilize drone swarms. Perhaps the most poetic resurrection of their legacy is happening in Guatemala's highlands. Modern Maya astronomers, blending ancestral knowledge with telescopes, have revived the ancient practice of celestial gardening, planting crops according to Venus cycles, just as their ancestors did. They're not replicating the past, they're extending it, proving these aren't dead calculations but living wisdom. Meanwhile, linguists and mathematicians collaborate to decode newly discovered glyphs, each translation revealing another layer of sophistication, like the recent finding that some temple carvings encode harmonic ratios matching the orbital periods of Jupiter's moons. The Mayans remind us that intellectual heritage doesn't disappear, it transforms. Their civilization may have faded, but their numbers still dance across our screens, their algorithms hum in our machines, and their stars still guide farmers in the very lands they once walked. In a world obsessed with linear progress, their legacy orbits onward, a brilliant reminder that true genius transcends time, and that the most enduring discoveries aren't just found in the stars, but in the minds that dare to count them. Fire and time have been ruthless archivists when it comes to Mayan mathematics. Of the thousands of bark paper codices that once existed, each potentially holding advanced astronomical formulas or undiscovered numerical systems, only 4 have survived the centuries. The infamous auto da fe of 1662, when Diego de Landa burned piles of Mayan manuscripts in the Yucatan, wasn't just a cultural tragedy. It was an intellectual inferno that erased entire libraries of celestial knowledge. What little remains, the Dresden, Madrid, Paris, and Grolier codices, are often damaged, their glyphs faded by humidity or nibbled away by tropical insects. Researchers now work with pages where critical calculations have dissolved into unreadable stains, like trying to reconstruct a symphony from a handful of scattered notes. Even when texts survive, deciphering them presents another layer of challenges. Early European scholars, steeped in Greco-Roman mathematical traditions, dismissed the Mayan system as primitive. They saw their bar and dot numerals as mere tally marks, failing to recognize the sophisticated place value system and the revolutionary zero hidden within. It wasn't until the mid-20th century that linguists like Yuri Norizov cracked the glyphic code, revealing that what looked like decorative symbols were actually precise mathematical notations. A single misinterpreted glyph could throw off an entire eclipse table. Early researchers once mistook Venus correction factors for ritual incantations, setting back our understanding by decades. The climate itself conspires against preservation. Mayan codices were made from fig bark pounded into sheets and coated with lime plaster, a medium vulnerable to the very humidity that sustained their civilization. Temples adorned with numerical inscriptions face relentless erosion from tropical rains, their carved equations slowly melting back into the stone. At sites like Palenque, archaeologists have found stelae where once sharp numerals are now smooth depressions, their mathematical meaning lost to weather and time. Perhaps the greatest hurdle has been overcoming centuries of academic bias. For generations, the dominant narrative held that advanced astronomy and mathematics couldn't have existed in the Americas before European contact. When the Dresden Codex's Venus tables were first translated in the 1930s, many scholars refused to believe ancient observers could achieve such precision without telescopes. It took interdisciplinary teams, astronomers running computer simulations of Mayan eclipse predictions, mathematicians analyzing the base 20 system's efficiency, and epigraphers decoding glyphs, to prove these weren't lucky guesses but the results of meticulous, generations-long observation. Now, new technologies are helping recover what was thought lost forever. Multispectral imaging can sometimes reveal ghostly traces of vanished ink on damaged codices, like the hidden numerical tables recently detected beneath the surface of the Madrid Codex. LiDAR scans of temple complexes have uncovered previously unnoticed architectural alignments that functioned as giant astronomical calculators, and in a twist of poetic justice, machine learning algorithms, descendants of the Mayans' own self-correcting calculations, are being trained to predict missing portions of damaged numeral sequences, effectively letting ancient mathematics heal itself. The irony is profound. A civilization that mastered long-term celestial prediction now relies on modern science to rescue its legacy from the ravages of time. Yet every fragment recovered, every glyph deciphered, reveals how much we still have to learn from their numerical genius. The real challenge may not be interpreting their math, but recognizing how much our own intellectual history has obscured theirs. Mayan mathematics has slithered into modern pop culture like Kukulkan, descending the steps of El Castillo, sometimes dazzling, often misunderstood. Films like Apocalypto reduce their cosmic calculations to mere backdrop, a jungle stage for blood and prophecy. Video games such as Civilization let players discover Mayan Zero as if it were a power-up, stripping away generations of sacred numerology and reducing it to a tech tree bonus. These portrayals latch onto the sensational, the so-called doomsday prophecy of 2012 while ignoring the real magic, a numerical system so advanced it could chart the dance of invisible planets centuries before telescopes existed. The obsession with Mayan apocalypses reveals more about modern anxieties than ancient wisdom. Hollywood loves the image of a carved stone calendar ending, but the long count was always cyclical, not terminal. When December 21, 2012 arrived without catastrophe, it wasn't because the Mayans were wrong, it's because we misread their math. Their calendars didn't predict destruction. They mapped renewal, a concept as alien to our linear thinking as their base 20 arithmetic. Even the glyphs used in movies are often jumbled nonsense, mixing Aztec symbols with fictional embellishments, turning a precise astronomical language into exotic set dressing. Gaming does slightly better but still falls short. In Age of Empires Roman II, Mayan priests chant over floating numbers as if their math required mystical incantations rather than meticulous observation. Assassin's Creed at least gets the architecture right. Players can scale pyramids aligned to solstices, but reduces their celestial calculations to puzzle solutions for unlocking treasure. These depictions miss the heartbeat of Mayan numeracy. Numbers weren't tools but living entities, their movements echoing divine will. A modern gamer tapping a button to activate a Mayan calendar is about as authentic as using an emoji to perform brain surgery. Yet pop culture's failures highlight why the truth matters. The Mayans didn't just invent zero, they weaponized it, using it to build self-correcting algorithms that kept their calendars accurate for millennia. Their Venus tables weren't cryptic prophecies but precision spreadsheets. Their doomsday glyphs actually correction factors for orbital irregularities. This nuance gets lost when movies reduce their legacy to carved skulls and jungle drums. The real horror isn't an imagined apocalypse, it's how much we've forgotten. There are glimmers of hope. Recent indie games like Heaven's Vault incorporate Mayan-style cyclical time mechanics, forcing players to think in spirals rather than straight lines. Documentaries are finally ditching the mystery tropes to showcase their math as rigorous science. Even Doctor Who gave a nod to their astronomy in one episode, depicting the Dresden Codex as an alien artifact, a playful metaphor for how advanced their knowledge truly was. The irony is delicious. A civilization that tracked planets they couldn't see is now obscured by the very stories meant to celebrate them. But every time a filmmaker or game designer digs past the cliches, they uncover something far more thrilling than fiction. A people who didn't fear the end of time but mastered its rhythms. And that's a story worth telling right. Among the towering stelae and temple inscriptions celebrating Mayan kings and male scribes, quieter clues whisper of women who mastered the sacred language of numbers. While most mathematical codices were penned by male hands, archaeological discoveries reveal priestesses like Lady Kaable of El Peru Waka wielded numerical knowledge as deftly as any ruler. Her famous portrait stela shows her holding not just the scepter of power, but the glyph for Star Warrior, a title tying her authority directly to celestial calculations. This wasn't mere symbolism. Recent excavations at her palace uncovered a sealed chamber containing obsidian mirrors used for astronomical observations and a cache of painted counting pebbles arranged in base 20 formations, suggesting she didn't just sponsor rituals but actively participated in the computations that guided them. The Dresden Codex itself holds subtle hints of female mathematical influence. Certain Venus tables include correction factors that align with lunar cycles, knowledge traditionally overseen by moon priestesses. One section tracks a 520-year calendar round using numerical patterns that mirror the average span of 13 generations of women, a rhythm male scribes were less likely to emphasize. Even the choice of materials speaks volumes. While men typically carved numbers in stone, women often worked with more perishable mediums like woven textiles and painted ceramics. A recently decoded funerary vase from Calakmul depicts a noblewoman weaving a tapestry whose geometric patterns perfectly replicate the multiplication tables found in codices, proving domestic arts doubled as mathematical training grounds. Beyond royalty, ordinary women contributed to Mayan numeracy in ways archaeology is only beginning to uncover. At Capan, a residential compound dubbed the House of the Scribes contained grinding stones stained with the same red ochre used in codices, but also spindle whorls and loom weights, suggesting women produced the bark paper for mathematical text. In the Guatemalan highlands, modern Maya weavers still use counting systems descended from ancient methods, their thread knots preserving base 20 calculations that once predicted planting cycles. These weren't passive keepers of tradition, they were living repositories of numerical wisdom, their textiles functioning as tactile mathematics passed mother to daughter. The greatest testament to their influence lies in what survived conquest. When Spanish clergy burned Mayan books, they targeted male scribal institutions but overlooked women's domestic numeracy. Colonial records describe Maya midwives using knotted cords to track gestational cycles with a precision that baffled European doctors, while female herbalists employed lunar calendars more accurate than the Gregorian system for timing harvest. Today, anthropologists find elderly Maya women who can still recite multiplication tables in the old Vigesimal system, their memories preserving algorithms the burning of codices failed to erase. What emerges isn't just a correction to the historical record, but a revelation about how knowledge endures. The Mayan women who calculated eclipse paths on painted pottery or wove sacred geometries into hewable dresses weren't exceptions. They were the quiet engineers of a numerical legacy too vital to entrust to temples alone. Their story reminds us that sometimes the most revolutionary equations aren't carved in stone, but passed hand to hand in the unbroken rhythm of daily life. For the Mayans, the Pleiades weren't just a glittering smudge in the night sky, they were a celestial almanac, a harbinger of rain, and a divine signal woven into the very fabric of their survival. Known as Tiz Ab, the rattlesnake's tail in Mayan glyphs, this star cluster's annual appearance before dawn marked the turning of seasons with a reliability that anchored their world. Unlike modern astronomers who might admire the Pleiades for their beauty, the Mayans tracked their movements with mathematical precision, tying the cluster's heliacal rising to the onset of rains and the planting of maize. Their codices revealed tables predicting this event centuries in advance, proving that what looked like mythology was, in fact, a sophisticated fusion of agriculture and astrophysics. The key to their obsession lay in timing. The Pleiades' first pre-dawn sighting, known as its heliacal rising, coincided almost perfectly with the arrival of seasonal rains in the Yucatan. Miss this window by even a few days and crops could fail. So the Mayans didn't just watch for the stars, they calculated their return down to the hour, using a combination of solstice markers and zenith passages to create a celestial early warning system. At sites like Uxmal, architectural alignments ensured that certain temples would frame the Pleiades only during these critical weeks, turning stone into a seasonal clock. Farmers didn't need to consult a priest, they simply looked at the sky and saw the universe itself whispering now. But the real marvel was how they compensated for precession, the slow drift of stars over centuries. Modern astronomers know the Pleiades' position shifts slightly each year, yet Mayan records show their predictions remained accurate for generations. Hidden within their calculations were subtle adjustments, like those in the Dresden Codex, where scribes tweaked intervals by fractions of days to account for this cosmic drift. They achieved this without telescopes, relying instead on generations of naked eye observations logged in bark paper books. Imagine the patience required, a grandfather noting the Pleiades' position, his grandson decades later detecting a minute shift, and his great-grandson encoding that correction into a mathematical formula. The Pleiades' influence extended beyond the fields. In Mayan cosmology, this cluster was tied to the rain god Chok, its appearance heralding not just water but divine favor. Ceremonies timed to its rising featured rituals where rulers impersonated the god, their headdresses adorned with star-like jade beads mirroring the cluster's pattern. Even their sacred ball game echoed this connection, the rubber ball symbolizing the Pleiades' movement, its bounce a metaphor for the star's journey across the sky. What's often overlooked is the cluster's role in navigation. Coastal Mayan traders used the Pleiades to calibrate their voyages, much like Polynesian wayfinders. Glyphs at Chalum depict star paths alongside numerical notations, suggesting they mapped trade routes using stellar positions as waypoints. A merchant sailing from Kaaba to Belize might time his departure to the Pleiades' zenith, ensuring winds and currents aligned with celestial guidance. Today, modern Maya farmers in Guatemala's highlands still plant by the Pleiades, proving the endurance of this ancient science. Satellite imagery even confirms their methods. Fields sown after the cluster's reappearance consistently yield higher harvests, a testament to observational wisdom refined over millennia. The Mayans didn't just study the stars, they let them dictate the rhythm of life, transforming glittering specks of light into the heartbeat of a civilization. Reconstructing Mayan mathematical algorithms feels like piecing together a celestial jigsaw puzzle where half the pieces have turned to dust. When researchers first examined the Dresden Codex's Venus tables, they assumed they were looking at simple addition, until they noticed the numbers didn't just accumulate, they corrected. Hidden between columns of dots and bars were self-adjusting equations that compensated for orbital discrepancies modern astronomers wouldn't understand until Kepler's time. These weren't static records, they were dynamic algorithms encoded in glyphs but operating with the precision of differential calculus. Take their Venus tracking method. At first glance, the tables simply list appearances of the morning and evening star. But when anthropologist Floyd Lounsbury fed these numbers into a computer in the 1970s, he discovered something astonishing. The Mayans had accounted for Venus's synodic period down to minutes per cycle. Their algorithm worked like this: 5 Venus cycles equal 8 solar years minus 2 days. They didn't just memorize this ratio, they built it into a recursive formula where each cycle's tiny error was automatically subtracted from the next calculation. It was a self-cleansing mathematical loop, written 13 centuries before the invention of the computer. The real breakthrough came when scholars realized these algorithms weren't unique to Venus. The same computational logic appears in their lunar tables, where they tracked not just the moon's phases but its subtle wobbles. One section of the Dresden Codex contains what researchers now call the Long Round, a 17,980-day cycle that synchronizes lunar months, eclipse seasons, and solar years. The algorithm uses a series of nested corrections, adjusting for the moon's elliptical orbit by adding or subtracting days at precise intervals. Modern astronomers call this perturbation theory. The Mayans encoded it in glyphs of twisting serpents and celestial monsters. What's most striking is how these algorithms mirror techniques we consider cutting-edge today. Their eclipse predictions employed what we'd now call a numerical integration method, breaking complex orbital motions into smaller, solvable chunks. Their long count calendar functioned like a cosmic clock with multiple interlocking gears, where each gear, a caton, bacton, or picton, turned at its own rate while maintaining perfect synchronization. Computer scientists at MIT recently modeled this system and found it operates similarly to modern-era correcting codes, automatically fixing discrepancies that accumulate over centuries. Yet the brilliance lies in their execution. Without abstract symbols for integrals or derivatives, the Mayans expressed advanced mathematics through positional notation and repetition. A single column of numbers might represent both a planetary position and the steps needed to adjust it, like a musical score where the notes contain their own tuning instructions. Their glyphs weren't just recording answers, they were preserving the process, turning each codex page into a programmable celestial calculator. The implications are profound. These algorithms suggest the Mayans didn't just observe the cosmos, they reverse-engineered it, treating planetary motion as a solvable equation written in the language of time. As researchers decode more fragments, they're uncovering a numerical sophistication that rivals our own, proving that true genius isn't bound by era or technology. It's recognizing patterns hidden in plain sight, whether etched in bark or glowing in the night sky. The night sky spoke in numbers to both the Mayans and the Babylonians, but the languages they heard couldn't have been more different. While Babylonian astronomers etched their predictions onto clay tablets using arithmetic sequences that climbed like staircases, Mayan scribes painted their calculations in interlocking circles, their numbers spinning like celestial gears. This wasn't just a difference in notation, it was a fundamental divergence in how two cultures perceived time itself. The Babylonians, masters of linear progression, tracked planetary movements by adding fixed intervals, a method that excelled at short-term predictions but required constant updates. Their Venus tablets from the 7th century BC show meticulous lists of positions, each entry building on the last like links in a chain. But the Mayans, architects of cyclical time, saw the cosmos as a grand wheel turning on invisible axles. Their Dresden Codex doesn't just list Venus appearances, it maps them onto a repeating spiral where every fifth cycle syncs flawlessly with 8 solar years, creating a self-correcting rhythm that needed no adjustment for centuries. What's fascinating is how these approaches mirrored each civilization's worldview. Babylon's math emerged from its bustling markets and administrative needs. Their base 60 system excelled at dividing commodities and calculating interest, skills that bled into their astronomy. When they predicted lunar eclipses, they used zigzag functions, arithmetic tools that added or subtracted fixed values to account for the moon's speeding up and slowing down. It was brilliant accounting applied to the stars. The Mayans, by contrast, lived in a world where time was sacred. Their long count calendar didn't just measure years, it wove them into nested cycles of creation and renewal, each caton and bacton resonating with mythic events. Where Babylonian astronomers sought to manage celestial data, Mayan mathematicians sought to commune with it, yet both achieved staggering accuracy through entirely different paths. A Babylonian tablet now housed in the British Museum predicts Jupiter's positions within 4 degrees over 60 years, a feat of persistence. Meanwhile, The Mayans' Venus tables in the Dresden Codex hit their mark within 2 hours over 5 centuries, a triumph of pattern recognition. The Babylonians got there by brute force observation, compiling centuries of data into sprawling ledgers. The Mayans found elegance in repetition, distilling the cosmos into fractions so precise. Their calculations for the lunar month 29.53086 days deviate from modern measurements by just 23 seconds. This cultural fingerprint extended to their tools. Babylonian astronomers relied on the zigzag function, a computational workhorse that approximated celestial speeds by adding and subtracting fixed values. It was pragmatic, effective, and as linear as the Tigris River flowing past their observatories. The Mayans, surrounded by jungles where seasons blurred into cycles, developed self-similar algorithms where small patterns mirrored large ones. Their correction tables in the Dresden Codex don't just fix errors, they nest them like Russian dolls, with each tier of adjustments harmonizing with the next. The real lesson lies in what these differences reveal about the nature of discovery. Faced with the same stars, two cultures built entirely distinct bridges to reach them, one anchored in the concrete, the other in the cyclical. Babylon's math whispers of empire and administration. The Mayans' calculations sing of sacred time and celestial rebirth. Yet both voices, though separated by oceans and millennia, arrived at the same profound truth. The universe keeps its books in numbers, and humanity's greatest task is learning to read them. For a Mayan king, the throne wasn't just a seat of power. It was a celestial instrument, carefully tuned to the rhythms of the cosmos. Coronations weren't scheduled by convenience or tradition. They were timed like precision strikes to coincide with planetary alignments, transforming a political ceremony into a divine spectacle. Imagine the scene. As Venus reached its zenith as the morning star, a new ruler would ascend the pyramid steps, his jeweled headdress catching the first light of dawn. The message was unmistakable. This wasn't just a man taking office, but a God-ordained event written in the stars. The king wasn't merely claiming authority. He was demonstrating his ability to harness the very forces that govern time itself. Behind every successful reign stood the priest mathematicians, the unsung strategists who wielded numbers like weapons. These weren't reclusive scholars scribbling in dim temples. They were power brokers who translated celestial patterns into political advantage. When a king contemplated war, his priests didn't consult omens, they calculated. The Dresden Codex contains chillingly practical tables showing which Venus phases correlated with military victories, based on centuries of campaign records cross-referenced with planetary positions. A ruler might delay an attack for months until Mars crossed paths with Jupiter, a configuration their records showed boosted morale and confused enemies. This wasn't superstition, it was data-driven warfare where the battlefield extended into the heavens. The genius of this system lay in its flexibility. When celestial realities clashed with political needs, the mathematicians adjusted. At Yaxchilan, inscriptions reveal how King Bird Jaguar Roman IV postponed his coronation twice, not due to unrest, but because cloudy skies obscured crucial Venus observations. His priests recalculated, waiting for the next auspicious alignment that would cement his legitimacy. Similarly, during droughts, rulers staged elaborate, rain-making ceremonies timed to the Pleiades' zenith, turning astronomical events into public demonstrations of their connection to the gods. The numbers didn't just predict outcomes, they manufactured them. Yet this cosmic governance came with razor-thin margins for error. A king who ignored his astronomers risked more than bad harvests. He faced rebellions. The infamous collapse of the classic Maya cities may have roots in failed celestial strategies. Tree ring data shows prolonged droughts during the 9th century, but some rulers doubled down on warfare despite their priests' warnings, triggering a catastrophic loss of faith. Glyphs at abandoned cities like Piedras Negras tell the story. The sky grew dark and the people scattered. The very mathematics that built their power became the yardstick of their downfall when rulers stopped listening. What modern politicians might dismiss as primitive astrology was, in fact, an ancient precursor to modern political analytics, a fusion of hard data and narrative control. The Mayan court didn't just use the stars, they performed them, turning each planetary transit into an act of statecraft. In their hands, astronomy wasn't merely observation, it was the ultimate soft power, written in a language of numbers that everyone could see but only the elite could truly read. The Mayan Vigesimal system, once carved into temple walls to track celestial cycles, now hums inside cutting-edge computer labs. While modern technology runs on binary ones and zeros, researchers are discovering that base 20 math holds unexpected advantages for certain computational tasks. Take error-correcting algorithms, for instance. The same nested cycles the Mayans used to adjust their eclipse tables are being adapted to improve data transmission in noisy environments. A team at Stanford recently published a paper showing how Mayan-inspired place value notation can compress certain datasets more efficiently than binary, reducing the energy needed for cloud storage. It's as if those ancient dots and bars contained a blueprint for 21st century efficiency. Historians, too, are leaning on Mayan math to solve long-standing mysteries. When archaeologists uncover a new inscription with a partially damaged long count date, they don't just guess, they plug the surviving numerals into reconstructed Mayan algorithms to triangulate the missing digits. This technique recently pinpointed the exact dedication date of a lost pyramid at El Mirador to November 22, 154 BCE, by cross-referencing Venus positions from the Dresden Codex with carbon-dated artifacts. The Mayans essentially left behind a cosmic Rosetta Stone where numbers don't just represent time but actively reconstruct it. Even space agencies are taking notes. Engineers studying orbital resonance, the gravitational dance between planets, found that Mayan Venus tables anticipated phenomena like the 8-year pentagram pattern Venus traces in Earth's sky. Modern trajectory calculations for satellites sometimes incorporate their correction methods to account for subtle gravitational tugs from unseen celestial bodies. At NASA Jet Propulsion Laboratory, a replica of the Dresden Codex's Venus pages hangs in the mission planning wing, a reminder that some solutions transcend centuries. But perhaps the most poetic application unfolds in Guatemalan classrooms, where Maya youth are learning ancestral numeracy alongside Python programming. A grassroots initiative teaches students to convert between base 20 and binary systems, blending ancient glyphs with circuit board designs. Last year, a team from this program won a robotics competition by programming a Mars rover prototype using Vigesimal logic gates, proving that the mathematics of temple astronomers might one day navigate the red planet. The true lesson of these modern adaptations isn't just that Mayan math was advanced, it's that their numerical philosophy was fundamentally different. Where we see digits as static symbols, they treated them as living relationships, constantly interacting like celestial bodies in motion. That perspective, it turns out, holds keys to problems we're just beginning to face, from interplanetary travel to sustainable computing. The past isn't just informing the present, it's helping build the future. The Mayans didn't just observe the stars, they engaged them in a dialogue written in the language of numbers. Their mathematical system was more than a tool, it was a bridge between the earthly and the divine, a way to translate cosmic rhythms into tangible truths. Where modern scientists might see cold equations, the Mayans found poetry, a celestial symphony where each planet's orbit was a verse and every eclipse a chorus. Their calculations weren't sterile abstractions but living conversations with the universe, blending myth and measurement into something far greater than the sum of their parts. Consider the way they tracked Venus not as a distant point of light, but as Kukulkan, the feathered serpent whose movements dictated the fate of kings and harvests. Their Dresden Codex didn't just predict its cycles, it wove them into a narrative where numbers held the power of prophecy. This fusion of precision and storytelling reveals a profound truth. The Mayans understood that mathematics isn't just about solving problems, it's about uncovering meaning. Their Vigesimal system, with its elegant dots and bars, wasn't just efficient, it was beautiful, a testament to the idea that the universe's deepest truths are often hidden in patterns waiting to be decoded. What's most striking isn't just the accuracy of their calculations, but the audacity behind them. Without telescopes or calculators, they mapped the orbits of planets they couldn't even see, deduced the gravitational tug of invisible worlds, and built self-correcting algorithms that rival modern computing. Their long count calendar, often misunderstood as a doomsday clock, was actually a masterpiece of cyclical thinking, a reminder that time isn't a straight line but a spiral, endlessly renewing itself. In an age where we rely on satellites and supercomputers, their achievements stand as a humbling reminder. Brilliance isn't bound by technology, yet the real lesson lies in what their legacy asks of us today. As archaeologists decode more glyphs and astronomers revisit their tables, we're forced to confront how much knowledge was lost and how much might still be recovered. The Mayans challenge us to see the night sky not just as a void to be conquered, but as a puzzle to be revered. Their math whispers that the universe is still speaking, if we're willing to listen in the right language. So the next time you look up at the stars, remember, you're not just seeing points of light, you're glimpsing the same cosmic dance that Mayan astronomers mapped with nothing but patience, curiosity, and a handful of pebbles in the sand. Their forgotten math isn't just a relic, it's an invitation to keep questioning, keep calculating, and keep marveling at the mysteries that still await. The universe hasn't stopped whispering its secrets, we just need to remember how to hear them.